Hi everyone. Today we're going to go over the steps that's necessary to take when you modify an existing DC or AC circuit. These are the steps that you would take prior to energizing the circuit. The reason this is important, it's vital that you do these checks to ensure that there isn't a misoperation on the power system and circuits aren't crossed. Okay, so the first step is to ensure that there's full voltage across the top side of your fuses. So if you remember, the top side of your fuses is going to be your source side, and the bottom side is going to be your load side. So first I just verify that my meter is working. So I would turn it on. And there I see minus 63 volts, which is good. Now I check across the fuses, so the positive leg is always on the right, and the negative leg is on the left. So across positive to negative, I see 129 volts, which is what I expect. Step number 2 is to verify that you have balanced source voltage. So I'm going to check my positive leg and negative leg to ground. What this is doing is it's proving that your substation voltage is balanced prior to putting fuses in. So first step is you could choose either leg. In this case, I'll choose the positive. And I see there is 63.6 volts DC. And on the negative leg, I see minus 63.1. So that's a fairly balanced station DC station service. Step 3 is to verify there is no AC or DC voltages on the load side of the fuses. So first, my meter is still on DC. So I check the negative leg, and what I'm seeing right now is there is some voltage because I have a capacitor in the circuit and it's bleeding that off. So I see it going down to 1, and next I'll move to the positive leg, and I see I've already bled off that capacitor. It's at minus 0.2. So the next step is to switch my meter to AC, and I want to verify that there is no backfeed from an AC circuit into my DC system because the wiring's been modified. So on my negative leg, I have 0. And on my positive leg, I have roughly 0 as well. As long as you're reading millivolts, less than 1 volt, all is well. Step number 4 is to verify there is a low resistance across the load side of the fuses. So switch your meter to the ohm setting. We've already verified there's no voltage on the load side, so it's safe to put my meter across it. So if I go across the negative and the positive leg, I am seeing 1.418 kilo ohms. As long as the reading is above I'd say 80 ohms, it's fine to close in. You're not going to be closing into a dead short. Step number 5 is going to be verify the load side of the fuses to ground. So again, in this case, what I'm going to check is my negative to ground. I see mega ohms, and positive to ground also has mega ohms. What this proves is that there's not any ground in your circuit and your new modified circuit prior to closing in your fuses. The final step, step number 6, you want to verify there's a balanced DC after closing the fuses. So here I have my trusty fuse puller, and I'm going to put in one leg at a time. This is my negative leg, and my positive leg. That noise you heard is devices picking up, getting DC power for the first time. Now if you recall on the last step 5, I'm still in ohms. So prior to using my meter in a live circuit, I want to switch back to voltage so there isn't a dead short on it. And it'll be the check I did before with balanced DC prior to. So I check my negative to ground and I get minus 63.1. I check my positive to ground and I get 63.7. So I can be confident that my DC was healthy before and after. All right, to review those 6 steps to returning a circuit after you've made a modification. Step number 1 is to verify there's full voltage across the top side of the fuses. Step number 2 is to verify there's balanced source voltage, positive to ground and negative to ground. Step 3 is the fuse blocks are still open, so verify no AC or DC voltage on the load side of the fuses. Step 4, verify there's a low resistance across the load side of the fuses. Step 5, verify the resistance of the load side of fuses to ground. Step 6, final step, is make sure you have balanced DC after closing the fuses. This is what could happen if you fail to follow these 6 essential steps. If you just go into a panel and put the fuses in, that could be a city without power.